Okay, welcome everyone to this seventh class of Java 1. Um, Hope everyone had a good week. Let's see. So, um, I've noticed that for the homework from last class on arrays that people seem to have some trouble with it. Uh, so I think I'm going to spend a good chunk of this class slowly going over the solution to homework 6, the one on arrays. So I guess before I get started, does anyone have any questions or comments or anything that they want to share? Oh, all right. Okay, let me share my screen. Okay. I know that the homework instructions seemed kind of dense, so I'm going to try to explain it. So to start off, we have two arrays. We have a string array with 4 elements in it, and we have an integer array with 4 elements in it. So there are a few objectives given these two arrays. The first objective is to write code to remove the shortest item in the first array. That's the first objective. The second objective is to remove the largest value in the second array. Um, and then third, we remove whatever elements we need to remove, we have to order these two arrays in ascending order independently. And then step 4, um, you create a hash table from the two arrays where the key is the items in the first array and the value is the items in the second array. And then lastly, we print out the second value in this hash table. So a total of 5 things to do. Kind of a lot, I understand. I didn't realize how hard this problem was until I wrote up the solution to this last night. So I understand if you guys weren't able to complete all the objectives that are set out. So we'll be going over that today, um, one by one. So does anyone have any questions on the objectives for this homework assignment? Any of the 5? No? All right. Okay. So maybe it'll be easier for me to put the objectives in the chat. Yeah, I'll just comment it in the code. All right. So first objective, uh, write code to remove the shortest item in the first array. So this will be an easy question, but can anyone tell me what the shortest item is in this first array here, the string array? You can just say so in the chat. All right. Yes, it is indeed the string good that we want to remove. So let's go over to my code here. I don't want to spoil anything yet, so I'll just move all that down and I'll bring it back up as I need to. All right, so in my Java code, I have my string array that I call R1. That's just the strings. And I have my integer array, R2, that's just the integers in the homework assignment. So let's bring some stuff up. Our first objective is actually, I think it's just this stuff here that I want to, yes, let's copy that. Okay, so our first objective is to remove the shortest element in the first array. So this is my solution to it right here in these 3 lines. And I'll probably just comment everything else under here so we can see how the code goes as we're going along. Um, okay. All right. So before I fully explain this code, maybe it'll be a good challenge for you guys to try to figure out exactly what I'm doing here. Can you guys in the chat maybe say what I'm doing here in line 14 with this arrays.sort R1? what it's doing to the string array? Just try to tell me in the chat what I'm doing in line 14 here. All right. Okay, we got a few answers here. So what I'm doing is I'm sorting array one from least to greatest. That's essentially what this sort does. So arrays.sort doesn't only work on integers, like on numbers, but it also works on strings too, which is pretty handy for our goal of um removing the shortest element in array one. Um, okay, so let me just comment this stuff out for now. And let's print out array one, and then we will sort it. And then we will print out array one again. Uh, let's see. So let's see what this prints out. Oh wait, no, it's not gonna. I have to. Yeah, I might have to use a loop to print this out. Yeah. Okay. Actually, I'll just print out the first element in both arrays. Okay. All right. So right now, so before I called the sort array, I mean the sort function on array one, the first element in array one is good because that's the string that we have here. And then after sorting it, the first element is daily because we already decided that daily is the shortest element in this array. So that's just me showing how sort is working. Um, isn't good shorter than daily? So since this is strings, the ordering goes from A to Z, with A being the shortest and Z being the largest. So since D is earlier in the alphabet than G, then daily is shorter than G. So it's not just the length of the string that's the meaning of length, but it's the first character. That's a good question though, Sophia. Um, okay. Uh, actually, yeah. Okay, so we have our arrays sorted. Um, so let's see what I did a kind of a neat thing here in line 15. Can somebody maybe say with their mic or in chat what I'm doing in line 15 here, or have this array list string r arl or yeah arl1 is equal to new array list arrays.as list r1. Maybe just give like a simple explanation of what I'm trying to do here at line 15, and of course I'll explain once I see some answers or hear some answers. Okay. So what I'm essentially doing here is that I'm creating a new array list. Remember, there's a difference from last lecture. There's a difference between arrays, regular arrays, and an array list in terms of like an array list being a more powerful version of arrays. So what I'm doing pretty much is that I'm converting our sorted array, AR1, into an array list that I call ARL1. So that's kind of what this thing right here is doing, arrays.asList AR1 that converts AR1 to an array list. And then this part here is this new array list is what actually creates it and everything. And then after that, I just remove the first element in the array list. So that's something that I wouldn't have been able to that I wouldn't have been able to do with regular arrays because array sizes are fixed. But since I converted AR1 into an array list, I can use this remove function for array list to remove the first element. So this achieves our goal of removing the shortest element. But actually, before I finish, I have to convert um, the array list back to an array, which is what this does here. So if I were to print out, let's print out both of these again. I'll fit it again. Okay, let's just do 0 and 0. Oh, wait, no. Oh, that's weird. Hmm. Actually, no. Okay. Yeah, so sorry, guys. I'm just getting I'm just confusing myself a little bit. Um, so so what I'm just printing out right now is maybe I should move this print line to be lower. Actually, no, it's fine where it is. Okay. So what I'm doing in this code now is that I'm printing out the first element of AR1, which is just good. And then I'm printing out the first element of AR1 fin, which is just the array list of AR1 that I converted back to an array with this toArray function. So in Java, there's a way to convert a regular array into an array list, and there's a way to convert an array list back to an array. So that's what I just did here after I removed the shortest element or the first element in the array list. And that's why the first elements of our array that's converted back to a regular array from an array list is developers, because we remove daily. So I know that might be a little confusing, but are there any questions about what's going on here? So what I've just done now is I've removed the shortest element from AR1. Okay. And this comment here kind of like explains everything that I'm doing in this code block. So first I sort. Uh, first I sort the array AR1. Then I convert the sorted array into an array list. Then I remove the first element. Then I convert the array list back to an array. That's essentially what I'm doing to complete our first objective. So now our second, oh, okay. One thing I want to mention is this weird syntax here. I have object brackets instead of string brackets. So I honestly use Google to figure out that I needed to put object here. I had to use Google a few times to figure out how to do some of the things I wanted to do for this homework assignment, which is pretty common in programming. I don't want to go into too much details as to why object works, but string doesn't. But just know that it just works for us here. Sorry, that's not a very good explanation, but it helps complete our objective of removing the first element. So now our second objective is to remove the largest element in AR2, which is the integer array. Now, can anyone tell me what the largest element in AR2 is? All right, yes, indeed 45. I'd be kind of worried if you weren't able to figure out that 45 is the largest number in here. So yeah, 45 is what we want to be able to remove. So I will show you guys the code for that. Here we go. And I use kind of a different method than the one that I used here. And I only did that just to show that there's several ways to solve the same problem, kind of. And I commented what I did here. But what I did was pretty much to remove the largest element in AR2, I first sorted AR2. So after sorting, it's going to be 2, 4, 10, 45. And then I make a new array list that's empty. So here in line 23, I make it an array list that's empty. And then I'm adding in the sorted elements of AR2 one by one. Okay, with the add function. And then I remove the third index, which is the largest index, the size of our array list pretty much. Because since I put in the elements of this sorted array in one by one, the largest element, which is 45, is going to be at the end of this array list. So that's what I'm removing here with this index 3. And then finally, I convert the array list back to an array. So if we were to print out the last elements of our final array, what we should see is 10, because 45 has already been removed. Yep, so it is indeed 10. Does anyone have any questions about the code that I have here? I know you guys may need a minute or two to really see what I'm doing, and I'd be happy to explain some more things about it if need be. Just know that I'm doing the same process as I did for the string array, except I'm adding elements to the array list one by one. All right. Okay, that completes our second objective. Our third objective is to order these two arrays in ascending order independently. So that part's pretty straightforward because we've already used the sort function a few times. So what I did was right here. Our third objective is to sort the arrays one by one. Our processed arrays one by one. And that's what I pretty much did here. They were already sorted though, because of the way that I did this. So yeah, that's about all there is to it. Now our fourth objective is to use the two ordered arrays to create a hash table where the first item, where the item from the first array is the key and the value from the second array is the value. So to make sure that we understand what that means, well, actually, no. Maybe I should print out both of these arrays. Okay, hold on. Give me a second, guys. I'm going to figure out how to print out an array in Java in a clean way. Okay, here we are. Okay. Okay, guys. So these two arrays that we see down here, this is the result of our first three objectives where we remove the smallest element from our original array, we remove the largest element from our second array, and then we sort them. So it looks pretty good. we have D, G, then P, and then 2, 4, and 10. So for our fourth objective for creating a hash table, remember that we want the keys to be the items in this array, and we want the values to be the items in this array. So can anyone tell me what in our completed hash table, what the value for the key good would be? So if like in our hash table, if we have the key as is good, what should the value be? Right. All right. The value should indeed be 4. Good job, Sophia. So it should be 4 because remember that the instruction says that the key should be the string array and the value should be the int array. So going through these one by one. The key, the first key in our hash table should be developers, and the value for that one should be 2 because developers and 2 are the first elements in both these arrays. And then the key, the good key should, how should I say this? The value for the key good should be 4, and the value for the key practice should be 10. Um, so yeah, let me just show you guys how to create the actual hash table. Okay, so this is how I created my hash table. So usually what would be in between these alligator mouths, I'll call them, should be string and int. But in my code, I have it as object and object because that's just what worked for me. It's due to some um, it's due to some complexities with Java uh, that I don't really have the time to go over until maybe unless you're taking Java 2. But anyway, I created my hash table here, and then I used the put function for hash uh, for the hash table class to put in the values of both my arrays in one by one. So I have the first value of my processed array, of the first processed array as the key, and then I have this first element in the second array as my value, and then so on and so forth. I just use some indexing tricks to put in my hash table. So if I were to print out my hash table that I called my hash, this is what we get. So good is equal to 4, developers is equal to 2, and practice is equal to 10. Is there any confusion as to why this is so? I'm not too sure how well you guys are gauging this. I just know that there wasn't too many submissions, though I do apologize that I wasn't able to that I wasn't able to post the homework um, as early as I usually do. Right? Yeah, if you're still confused about how hash tables work, then you could review the recording for the last lecture. Should keys be unique? Yes, keys should be unique. Now values don't have to be unique. It's possible uh for like multiple keys to have the same value, but uh there shouldn't be uh how should I explain this? So one key cannot go to multiple values, but multiple values can go to one key. I mean, no, other way around. One key should, one key cannot go to multiple values. No, I'm confusing myself now. But to answer your question, Minwan, keys keys should be unique. You shouldn't have one key mapped to multiple different values. Yes, I think so. Okay, anyway, that's the hash table. And then our last objective is just to print out the second index or the second value of this hash table, which is developers. And we can do that by just using the get function for hashes and then giving it the developer's key. So our answer should be, oh, that's confusing. That's not, hmm. Uh, oh, okay. This is actually right because, all right. Oh, never mind. Yeah, this is actually correct because good is actually the second largest in here. So when we return the second index in AR1. Anyway, so we're okay. We have a question. Yeah, why is there a 4 at the end? So in my last print line, I'm using the myhash.get function to print out the to so I'm giving it a key pretty much. I'm giving the myhash.get function a key, with the key being the second element in AR1 fin. And the second element of AR1 fin, I'll probably just print it out right now. Uh, well, so the second element of AR1 fin is good because it's a sorted array. And then I'm given that value as the key value for our get function. And since good is mapped to 4, that's why it's printing out 4. That's essentially what's happening. So that's pretty much the homework. It was a bit of a longer one, and I promise the next homework won't be as challenge. I won't say it won't be as challenging, but it won't be as tedious, I'd say. Um, so our next lesson for today is actually on if statements, which is honestly will probably be you guys' favorite lecture because if statements are pretty intuitive for new programmers, and conditional statements. Um, but yep, that's pretty much this homework. Is there any questions about the solution to this homework? No. All right. Yeah, I'll make sure to post this in the Google Classroom as well. Let's see. So give me a minute and I will start with our lecture for class 7. And I know I spent about half the class reviewing the homework, so I don't expect us to complete all the slides for this next class. Well, actually, I won't post the solution right just yet. I'll let you guys work on it yourselves. Maybe give you guys another day or another week maybe to work on the solution. So I'll extend the due date for homework 6. Um, and give you guys some more time to work on it on your own now that we've gone over it a bit. Uh, and uh, and yeah, so I'll hold off a bit on posting the solution. So let us move on to home to lecture 7. All right. All right. Well, we've pretty much reviewed arrays and array lists and dictionaries and hash tables because we just went over the homework. So let's just go on with the lecture. All right, code flow. So far, when we write code, we organize them from top to bottom. The system also reads in the code from top to bottom and executes them line by line in that order. In the real world, we may only want to execute only want to execute um, a partial segment of the code, or we may want to execute the code repeatedly. Code flow or control flow comes into play. What this slide is saying is that um, in code such as this, we execute everything from top to bottom, one by one and line by line, but that's not always what's desired. So we can like kind of jump around lines with code flow and control flow. That's what the slide is saying. Well, here's an example. Say if I have 30 students in my class, I want to give the blue ball to the students who are under 12 and give the green ball to students if they're 12 and above. This involves decisions. How does Java handle decisions? We will go over some of that today. So to make a decision in Java code, Java uses the following conditional statements. Uses the uses the if statement to specify a block of code to be executed. If a specified condition is true, we use else to specify a block of code to be executed if the same condition is false. We use else if to specify a new condition to test if the first condition is false, and we use switch to specify multiple alternative blocks of code to be executed. So this will be easy to understand once we have an example up. Let's see, so this is an example of so this is kind of what the previous slide is talking about. We have an if, and then a condition, and then a statement. That's one way to do an if statement. We have if, condition, and then brackets and then statements. This third block here shows how else would work. Uh, so maybe it would, let's see what we have in the future here. Okay, well, it looks like we have some examples in code coming up, so I'll just hold off. So yeah, this is another way to format an if statement block. So that's that's one of the ways that Java does control flow with the thing called if statements. So this is another way to do an if statement block. And this is kind of like a diagram that explains how if statements work. We start with a condition. If the condition is true, we go inside the code. We go to the code inside of the if body. And then if the condition is false, however, we go to the code after the if statement. But either way, whether it's true or false, we will eventually get to the code after the if statement. So we will see that in action soon. Here we go. So let's run this and see what we get. All right. So let's see. We declared an integer x that's 20 and an integer y that's 18. And then we have this if statement. If parentheses x is greater than y, then we have code inside this code block. Print out x is greater than y. So can you guys tell me whether or not this code block, I mean this line in line 11 in the if statement block will be executed or not? It will be yes. And very good to you, Aaron. You anticipated my question. I saw you post yes before I even finished. Good job to everyone that said yes. So it's, yeah, the code will be printed because x is greater than y, 20 is greater than 18. Now, let me give you guys an example. Actually, let me just print this. Let me just run this code. Yeah, it is indeed printed. Now, let me introduce something else. Now, can you guys tell me if this line that I just added in line 14 will be printed or not? So I just have the else here. Okay, very good. It will not be printed. Okay, now another challenge. Let me switch this sign around. So now we have if x is less than y, print out this, line 11, else print out line 14. Now, can you guys tell me which line will be printed? X is greater than y or y is greater than x? Okay, the else. Yes, very good, guys. So the else will be printed because the value of this condition is false. X is not greater than y. So the code in this block will be skipped inside this code block. And then we go straight to the else. And that's always executed if the stuff in here is not executed. Now let me do one more thing. Okay, now can you guys tell me what lines here will be printed? I added an else if x is equal to z, and I declared a z that's equal to 18. So will the code in this line be printed, or this one in line 15, the one I just added, or in line 18? Uh, will all three of them be printed, or just one, or just two? This tests our understanding of if statements. Well, we have all the answers this time. We have two people saying the first line. We have two people saying the second. Two people saying the third line. Uh, so what will be printed actually is the second line here. And it's only going to be the second line. Is it? Yeah, I think so. Is it going to be the second line? No. Oh, no. Oh, wait, why not? S is equal to. Oh, whoops. I meant to put Y here. Oh, well, congratulations to the people that correctly uh, got that the third line is correct. So when this was originally X, the third line would be printed because X is not equal to Z, uh, and X is not less than Y, so it goes to the else. I guess I kind of spoiled my challenge here. Well, I'll post it again. All right. So if we were to change the X to a Z, the X to a Y here. Now, can you guys tell me what line will be printed from these three? Yes, the second line. Um, so only the second line will be printed because there's a true statement here. So it's not like just because I have an else here that'll always be printed if the first line is wrong. The else only gets printed if everything above it is false. Okay. All right. So I hope I gave you guys some practice with understanding the basics of if statements. Let us move on. Now, a Boolean expression. A Boolean expression is an expression that results in a Boolean value, that is a value that is either true or false. More complex Boolean expressions can be built out of simpler expressions using the Boolean operators. So guys, just always remember that a Boolean is just a true or false value. That's really all it is. It's a weird name, but that's always the result of it. Let's see. So these are some operators. We have a double equal sign that returns true if the left is equal to the right. Then we have the exclamation point equals that returns true if the left is not the right, is not equal to the right. We have greater thans, less thans, and then greater than or equal to's. So this kind of chart would be just one of those things that you just have to commit to memory. And you'll eventually be able to understand what these things mean just with enough practice. So maybe I wonder what we have coming up that helps give. Okay, so we have some examples. Here's some more Boolean operators. We have the and that returns true only if both sides are true. We have the Boolean or, the Boolean not, and the exclusive or. It'll be best if we just go for examples so that you guys understand what all this means. So let's run this. Okay. So let's look at this first one here. This b is equal to x. So we're declaring that b is a Boolean, right? So b will always be either true or false. So this first question on line 21 is easy enough. Can you guys tell me if the b here will evaluate to true or false given this x is greater than y? So in this code, x is equal to 4 and y is equal to 6. So we're asking really if 4 is greater than 6, what b will be. All right, it should indeed be false because 4 is not greater than 6. Yep, false. Okay, good job to everyone that got it right. Aaron, Angela, Sophia, Tyson, Henry, not Eddie, Alan, Andrew, good job. All right. So now the second question has uh, this weird looking and operator here. So let's review what this double ampersand means. The double ampersand. So the double ampersand is the name of it is and it means true if and only if both sides are true. So looking at this, what this essentially is saying is that we have to look at this left side, x is greater than y, and this right side, y is greater than z. Now, the only way that b can be true is if both of these sides are true. If even one of them is false, then b is false. So can you guys tell me, given that information, if b will be true or false? Okay, all right. Now, can someone explain why b is false? Okay, it's false because of this x is greater than y here. That is not a true statement, so the whole thing evaluates to false. Um, Now, if I were to switch the sign around to x is less than y, can you guys tell me if b is true or false? All right. It should be true because both sides of the equation are true. Well, yep, that is just about how and works. Right now, let's look at this one. It's a similar looking problem to the previous one, but instead we have these two lines here. So let's see what these two lines here mean. So the two lines, the name of this operator is an or, and it's true if either side is true or if both sides are true. So for us, that means that B would be true if either one of these expressions on the left or right is true. So given that information, can someone tell me if B will be true or not for line 23? All right. Um, it should evaluate to true because uh, X is less than Y, which is true, um, even though Y is not less than Z. Now, if I were to switch the sign around to X is greater than Y and kept everything else the same, can you guys tell me if B is true or false? All right, it should be false because both sides of the expression are false. Yeah. So good job to the people that answered that. Now for our last one, that kind of puts together everything that we've learned. Can you guys tell me whether or not this final expression can evaluates to true or false? I understand it'll take a minute, so I'll let you guys think about it. Um, all right. All right, this evaluates to true. Um, Now, can anyone tell me why B evaluates to true? Okay, I'll give us a simple walkthrough about why this evaluates to true. Uh, because, so we'll start with the expression in the parentheses. Um, see, X is not greater than Y, so that part is false, but Y is greater than Z, which is true. So this first expression evaluates to true. And then on the right, we have X is greater than Y, or X is greater than Z, which is true. So that means we have true on the left and true on the right. And if we AND them, it is true. Um, so yep, that took a bit of creativity. So good job, Sophia and Aaron, for explaining that. I forgot to run the code. But yeah, it does evaluate the true. All right. Um, that was that. Now, when an expression contains two or more operators, the order in which operations are done is defined by parentheses, as we've seen. and by the precedence of the operators. Thus, for example, the following two expressions are equivalent. And I guess we could prove that by writing the code for both of these. Um, all right, this he doesn't have a problem with that one. Good. So before I run this code, can you guys tell me, since we all know that these two expressions that these two expressions are the same, can you guys tell me what either of these will end up printing out? X is greater than 1 and X is less than 100, or X is equal to 300. Hmm. Uh, Remember that both expressions are the same, guys. In the slide, it says that the following two expressions are equivalent. It's just that the point they're trying to get across is uh, that there's a precedence in the operators when there's no parentheses. So if we were to take a look at this first expression here, it's the same as the second one. So remember in our code that x is 4 and yeah, that x is 4. So if we were to go through this, we're saying x is greater than 1, which is true, and x is less than 100, which is also true. So the stuff on the left-hand side is true. Um, or we don't even need to look at the second part because we know that the first part is true. So the whole thing will evaluate to true. So they're both true. Or are they? Let's see. Am I wrong again? Okay, they are. They are true. Good. Yeah, because these two are the same expression. It's just that the first one doesn't have parentheses. Now, one thing to note is that the way that the expression is formatted here is bad style. If you were to if you were to write code like this in like a programming job, your coworkers would be mad at you because stuff like this first line, this first expression here is kind of hard to read. The second expression is a lot easier to read because there's parentheses. So that's one thing to keep in mind. Yeah, let's see. Okay, and this slide already even talks about it. Um, so it talks about poor style is doing things like if danger is equal to true, or if danger is equal to false. You don't need to do that because danger is already a Boolean. So you can leave out the equals part, if that makes sense. Uh, it may seem kind of confusing now, but you'll get the hang of it as you practice these some more. All right, let's run all this code and see what we get. I believe this is more examples of if statements. Okay. Okay. Um, so these here are looks like to be three different code blocks. So this right here is one code block, this single line right here, and then we have this is the second code block, and then I believe this one's the third one. Let's see what the slides say. Okay. All right. So if we were to see, so we're asking in line 29 if x is equal to y. We know that's false. 4 is not equal to 16. So if we were to print that out, I'll comment everything else out for now. And I'm probably going to end the lecture after I explain all of these code blocks. Um, so let's see. Yeah, since x is not equal to y, then this stuff does not print out, which makes sense. If you were to change this to less than, it should have print out something. Yep. So yep, that was kind of obvious. We have the second code block. If x is equal to y, they are equal. If not, then if else, print out they are not equal. So this second part should print out they are not equal, as we have decided in previous examples. Now this third block is a bit tricky because there are no parentheses. I mean, there are no brackets. Um, so can anyone take a guess as to what this third block will print out? If x is equal to y, then print they are equal, else print out they are not equal. The main difference here is that there's no brackets like there are for here. So can anyone tell me what lines 39 and 40 will print out? Let's see what they print out. Even I'm not too sure. Oh, I need to comment this stuff up here out. All right, so it prints out that they are not equal. So it turns out that we don't actually need to have the brackets here, like in the previous example, for if statements to work if you have an else. But it's just bad style not to have brackets. So when you have an else here that doesn't have any brackets attached to it, it just gets paired up with the first like if that's above it. So that's why x and y are not equal is printed out down here, even though there are no brackets. All right, so we've completed more than half of the slides on if statements. So does anyone have any questions about what we've gone over so far with if statements? I'd say they are pretty intuitive. The hardest parts may just be figuring out all the operator names and what they do and stuff, but that just comes with practice. Oh, all right. Well, it's about 7:30, so I'm going to let you guys go. I hope today's lesson was helpful for reviewing the homework from last class and also giving you guys a primer for if statements and conditional statements in Java. Um, yep, that's about all I have today. Have a good evening, everybody.